Hey geometry students, welcome back because we are now getting into a whole new unit. Woo! We're going inside triangles. If you recall the last unit, we were talking about congruence and triangles and all that stuff. Well, you may think triangles are so simple, but we're going to realize they got a lot to them. And so that's what we're going to learn in this unit. We're going to go inside triangles. So today we're going over mid-segments of triangles and what's the deal with mid-segments. So here's what we're going to be talking about. We're going to talk about identifying parallel segments. Got to know what parallel means. We're going to be finding lengths, yay, algebra, and then using mid-segments of a triangle. There's actually some kind of real-life stuff in there. So anyway, we're going to do what we always do first. Notes, yay! So we have a note about midsection, the triangle or midsegment, the triangle midsegment theorem. And so the theorem reads: if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long. What? So we have all this stuff. Basically, what you have to realize, if we are connecting midpoints, how do we know if we have midpoints? If we have congruent sides on either side, that is the midpoint. And so we got to be careful. If we are connecting midpoints, then we have a midsegment. And the cool thing about midsegments is that they are parallel and half as long as the third side. Okay, so we're thinking parallel and half of the other side, and that's the big deal. Okay, so you have your algebra stuff, but you have your words as well. So you're thinking midsegments by midpoint, parallel and half. Okay, so we're connecting midpoints. We're knowing their midpoints because we have congruence on other sides. Connect them together. We have a midsegment. So to the third side, we got parallel and half. Isn't that cool? You didn't ever even thought about that for a triangle, right? Because we're just thinking about angle, side, angle, and all that stuff. Well, no, there's so much more. What happens if we connect at midpoints, right? So neat things happen. So that's the note. Let's apply it. So here's a question, right? We're going to start off with this question: what are three pairs of parallel segments in this triangle DEF? Okay, so what are three pairs of parallel segments? So remember the deal with midsegments. Midsegments are parallel to the third side. And so eyeballing this particular diagram, we might think that, well, this RS looks parallel to DF, right? It looks parallel, but hang on. How can we be so sure, right? So we got to wait. How can we be so sure? Is R a midpoint, right? So we have to always wonder, are we sure that we have a midsegment, and how? Okay? So we got to be sure. Is R the midpoint? Yeah, dude, R is the midpoint because we got 1 and 1 over there. Is S a midpoint? Yeah, because we got 3 and 3 over here. Is T a midpoint? Yeah, we got 2 and 2 over here. So we know we're dealing with midpoints. Then these are all midsegments. Now it's not only eyeballing things, we can totally lock down. So we can hopefully easily see that we have now segment RS would be parallel to segment DF. And that's how we write that. Segment RS is parallel to segment DF. That's one pair, right? And the question asks, well, what are three pairs? Well, there's other pairs, right? Remember, R and T are midpoints, right? So we have RT on this side and EF over there. So that means RT is parallel to EF. And then lastly, we know that T is a midpoint and S is a midpoint. So we have TS, and that's parallel to DE. Right? So TS and DE are parallel. And so that's how we would address that. And so we ensure that we are dealing with midsegments. Once we're sure we're dealing with midsegments because we're connecting midpoints, then we have some cool things that happen, right? Midsegments are parallel and half. And so that's what the first question looks like. And so let's do some more work. Bam, how about this? In triangle XYZ, A is the midpoint of XY, B is the midpoint of YZ, and C is the midpoint of ZX. What are the three pairs of parallel segments? What? So we look at this and we're thinking, what is going on? Remember, y'all, when in doubt, draw a picture. So when in doubt, draw a picture. It's saying triangle XYZ. Let's call it that. X, Y, Z. We got triangle XYZ. Right? And it says, well, A is the midpoint of XY. Okay, let's look for XY, and then we have A as the midpoint. So we have an A here. We can guess that, right? And then B is the midpoint of YZ. All right, so we got YZ. So let's say the midpoint is there. We call that B. And then C is the midpoint of ZX. So we look for ZX, and we say, okay, so there's CX. as the midpoint. So now the question is, what are the three pairs of parallel segments? Well, we know A, B, and C are midpoints, right? So when we connect A to B, we know we have a midsegment. We know for a fact we have a midsegment, okay? Because A and B are midpoints, okay? So when we connect the midpoints, we got midsegments. And that simply means that AB is parallel to the third side, to XZ, or in this case, they called it ZX. So, but we called it XZ, let's call it XZ, right? So AB is parallel to XZ. Now we have other midpoints, right? So we have A is a midpoint, C is a midpoint. Therefore, AC is a midsegment, right? And if AC is the midsegment, it is parallel and half of YZ, okay? And then B is a midpoint, C is a midpoint. So we have CB is a midsegment. And midsegments are half and parallel of the third side. So we have CB parallel to XY. And those are our three pairs of congruent, or excuse me, of parallel segments. Okay, so we're getting good with vocab by now, I hope. If not, rewind and all that stuff. So hopefully we're getting better. Now we're going to find lengths. Okay, so in this example, we got triangle QRS. T, U, and B are midpoints. That's an important part, right? T, U, and B are midpoints. That means T, U, UB, and TB are all midsegments. Okay, remember how midsegments work? Be sure to have midsegments. Midsegments are parallel and half. Okay, so we know this now, right? So we're all set. That's the deal. But now the question is, what is the length of TU, UB, and QR? Whoa. So what is the length of TU? Well, here's TU. It is a midsegment. It's parallel to and half of SR. SR is 40. Half of 40 is 20. You guessed it. So TU is 20. Okay, so that's how that works. TU is 20. What about the length of UB? Okay, so UB is from U to B, and we know that that is a midsegment. Midsegments are parallel and half, so we're going to think half of 50. Okay, half of 50 is 25, so UB is 25, right? And then what is QR? Okay, so QR, where is QR? I have a TUB. Where in the world is QR? Oh, QR is up here, right? So QR is way up here. And look what it's parallel to, TB. How do we know it's parallel to TB? Because T and B are midpoints. This is a midsegment. And midsegments are parallel to and half of the third side. So if TB is 30, then now we're looking at twice 30. Okay, so we know that QR is going to be 60. Okay, so from Q to R, that's how you read those little things, by the way. From Q to R is 60. Okay, so that's how that works. That's how you can find lengths. As long as you remember, midsegments are parallel to and half as long as the third side. Another example. In this picture, AD is 6, DE is 7.5. What's the length of DC, ACE, F, and AB? What? Okay, so what's going on here? First question is this. Are we dealing with midsegments, right? That's what we have to be sure. Are we dealing with midsegments? Is D a midsegment? Yes, because we got 2 and 2. D is the midpoint, so D is the midpoint. Is E a midpoint? Yep, we got 1 and 1 here. E is a midpoint, so D is a midsegment. Is F a midpoint? Yep, 3 and 3. So D, E, and F are all midpoints. We are set to go. That's what the setup is. And now what do we know? We know AD is 6. So you know from A to D is 6. What is the length? And D to E, excuse me, is 7.5. So D to E is 7.5. With that, we have unlocked this entire triangle. We can do everything we might need. Well, not everything, but we can answer the question for no doubt. So the first question is this. What's the length of DC? Well, DC is up here, right? And notice that DC is parallel to AD, and AD is 6. So DC must be 6. Okay, so we know that by thinking and knowing what these little tick marks mean. What is the length of AC? Well, from A to C. All the way, AC, 6 and 6, 12. What about from E to F? So we have from E to F. Okay, that's a little tricky, right? So now we know from A to C is 12, right? So we know all the way from A to C is 12. How can we find FE, right? How do we find FE? Is FE a midsegment? Yes, yes it is. So EF is a midsegment. Midsegments are parallel in half, right? So we got to figure out what is half of 12. So for EF, we got to figure out half of 12. Guess what half of 12 is? 6. How cool. How cool. Okay, so FE is 6. And then find the length of AB. Well, from A to B. Well, that's interesting. A to B. All the way from there. Well, do we know anything about DE? Yeah, we do. DE is the midsegment. Okay? So DE is a midsegment. So that means, right? What does that mean? That means that A to B is parallel and twice as long now, right? Because DE is half as long as AB. So from A to B is going to be twice 7.5. Okay, so that's how we can figure that out. Twice 7.5 is 15 units. Okay, because, well, 7.5 and 7.5 is 15. So we know AB is 15. And then we can solve everything we need about that triangle because of what we know about midsegments. Parallel and half as long. Cool? Cool. Let's do some real world stuff. Yeah, real world. So here's the thing. This is quite honestly real world stuff. A geologist wants to determine the distance AB across a sinkhole, right? From A to B, there's a sinkhole. Choosing a point E outside the sinkhole, okay? Choosing a point E outside the sinkhole, she finds the distances AE, from A to E, and BE, from B to E. She locates the midpoints C and D. So here's the thing. You can actually ensure midsegments because you're the one measuring this. Okay, so whenever this happens, if you need to build a bridge or, maybe you're designing some kind of what have you around a thing, you can totally use this because you're the one that's measuring this. So by design, you can choose where your midpoints will end up being. So anyway, she locates the midpoints C and D of AE and BE, right? So she knows where the midpoints are because she's the one that measured it. Okay, and so she's able to measure CD. She can set those midpoints to a place where she can actually measure from here to here without having the interference from the rest of the sinkhole or a rock or something. So she can set that up. Anyway, so that's the deal. The question now is, what's the distance across the sinkhole? Well, since C and D are midpoints, right? Since C and D are midpoints, we know we have midsegments. And if we know we have midsegments, they are parallel in half, right? So this is half of AB. Okay, so CD is half of AB, right? And if CD is 46, well then we need twice 46, which would be 92. Okay, so we have 92 feet is the case. So what's the distance across the sinkhole? 92 feet. Okay, and we can design that stuff, right? So anyway, so we can design things to go across like bridges and whatnot. Rough estimates. I mean, there's more to bridge building, clearly, but you get the point. So speaking of bridge building, here's another example. CD is a new bridge being built over a lake as shown. What's the length of the bridge? Okay, so take a look at what's happening. In this diagram, we have a length here. So someone clearly drew a triangle such that D here is a midpoint. So we can calculate a distance to this direction and a distance to that direction. And C is a midpoint. And we can calculate a distance this direction and a distance this direction so that we can have a vertex here. And we know that's a midpoint because we have 963 here, 963 here, one tick, one tick. So C and D are midpoints, right? Remember, we have now a midsegment, which is parallel in half. Okay? So the question is, what's the length of the bridge? Well, by setting up these lengths, we can then build a triangle around the thing, the lake. And if we know the third side is 2,640 feet, well, we know the bridge is going to be half of that. Right? Whee, vocab. Half of that, right? So mid-segment is parallel in half. So we take half of 2640, which is 1320, right? So there, I did that in my head. So we have 1,320 feet. That would be the length of the bridge. Now you know how much wood to buy or whatever if you're going to make it out of wood. Yay, real world. All right. I don't even remember what's next. Hey, it's a quiz. All right, so we're going to do a quick quiz. This is what some of the, your test questions might look like. So use the figure below. In this figure, if the length of xz is shown, what other segment can you assign a length? So we have xz, right? Where is that? Xz is here. What other segment can we assign a length? If we know XZ, you know what else we know? We know AC, because that's parallel in half, right? So it's good. AC is twice that. So we should be looking for AC, right? AC, 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 A. What? We don't have an AC there, right? But you know what we do have? We have an AY. Because guess what? If AC is twice XZ and AY is half of AC, well, if we know XZ, we know AY. Isn't that weird? Pause and rewind that, because I'm going to say it again. If we know XZ is half of AC, and we know AY is half of AC, well then XZ and AY are the same. Bam. Quiz. Here, one more quiz question. We'll call it a day. So here's this neat question, right? We got this big triangle with midpoints, right? It's giving us midpoints. So we know these are all midpoints. J, K, and L are all midpoints. So we know we have mid-segments. Yay. Now we just have some measurements. It says JL is 11. That's helpful to know. LK is 13. That's helpful to know. And ON is 20. ON is 20. Oh, so way down there is 20. So from O to N is 20. Well, it just says and JL is parallel. We don't need that information because we have JK and L are midpoints. So we actually don't need this parallel information. We just need to go on to the question. What is the length of MN, MO, and JK? So what is the length of MN, right, way out here, MO, way out here, and JK, way in here? Okay, so we can all figure that out. If JL is 11, MN is 22. If LK is 13, MO is 23. And if all the way out, NO is 20, JK is 10, right? So JK being 10, MO, 26. Ooh, that was close, cats. What's wrong with you? 26 and 22. So we know the answer is D, that last one, because that was really a mistake. Anyway, I'm done. That's all mid-segments. Yay! So we now know all about mid-segments of a triangle. More importantly, we know there's a lot of stuff that can happen inside a triangle. Okay, so we will continue later with more stuff about what goes on inside, and I'll see you later.